Okay, I guess we can start. So as we always start with our motto of our user group events, we always want to share what we know and we learn from each other. It's not that only speaker always tells something. If you have anything to say at that in any point of time, you can mention in the chat. And if speaker is comfortable talking about that at right that point of time, he will just join there. Otherwise, we'll just take it at the end, but we never leave anything out in there. And we also want to make lasting connections. It's not that virtual events are just for one-way talks. By this time, you got to understand that these events are going to stay for long. So we have to get used to making lasting connections even from virtual events because we spend time here and we don't want to just make it like a one-way talk. So feel free to chat and get to know each other well. And also, if you're comfortable at the end when we have networking, you can turn on your video so we can make lasting connections. The agenda for today is simple. Initially, we will be having Elastic Talk by Aravind, then demo, Q&A, and we have a feedback form for raffle where we give some prizes. Just an etiquette, even though we all know because we are used to attend virtual events, but even anyone is attending for the first time, turn on your video camera, keep your microphone muted during the talk, and you can always post your questions in the chat. And this meetup is being recorded, I guess, and if you don't like to be in the recording, you can turn off your camera. And for the raffles, we will be giving away 2 JetBrains licenses today, which you can use for all the tools that are mentioned in there, ReSharper, WebStorm, and IntelliJ, PyCharm. There are a lot of tools which already JetBrains provides a community edition, but you can get 1-year professional license with the raffle that we are giving away today. And we also are giving 10 ebooks totally, and each ebook of 5 copies. One is Elasticsearch 7 Quick Start Guide, and one more is Learning Kibana 7 second edition. We are giving away these 2 books. And also, if anyone would like to have a physical copy of it, we would be providing a 20% discount code for the physical copy to all attendees, which we would be giving away at the end and also sending an email. Okay, and now here we are introducing our speaker, Aravind. He's joining in from India today. Thank you so much, Aravind, even though it's night for you, for joining us. He works at Elastic as a developer advocate and looks after developer relations functions in India. He has experience working in cloud security and financial domains, and also experience in search and analytics, even machine learning as well. And he told us he liked to play with Raspberry Pi and Arduino. So if anyone is tinkering with hardware stuff, you can also reach out to him regarding that. And hope he's fine with it, even though it's not his job related, but it's always fun to tinker with hardware products. Okay, now I take this opportunity to hand over it to Aravind to start the session. Thank you so much, Aravind. I will stop sharing and you can start.
Thank you, Vishal. That's a huge amount of introduction, and I'll quickly share my screen, and I hope should be able to see the screen, right? Can you see the screen?
Yes.
Exactly. So welcome everyone, and thanks for joining. From all parts of the world. And if you have any problems in what I am explaining here or showing here, please feel free to write it in the chat box or unmute or stop me, because I'll definitely try to explain and say if it is coming ahead in the coming slides, I'll tell that. But the intention here is to, do an event where everyone could participate and also everyone could share knowledge and learn, like Vishal said. I have my colleague Phoebe here. You can also ask questions, or if you have any troubles hearing, you can point out if I'm not able to see you. So that being said, don't worry about the title that we have here and the title that you have seen in the meetup. So it's more or less similar. We'll try to definitely explore, the Elasticsearch using Google Cloud, definitely. But what I'm trying to explain as well is, a specific solution using Elasticsearch basically, and it's also very popular in the entire, the analytics and DevOps world. So specifically, we will do some slides. I'll explain you something, and then I'll show you a demo. So I believe you're all with me, and then we can get going. So quickly talking who I am Aravind, and I think Vishal has done a lot of intro, so I don't want to do much, spend more time here. But I blog at aravind.dev, and then I'm there on Twitter, as you can see, that's my handle. So I'll also paste my link so that if you have any questions later, you can also DM me. I'll also paste the forms and everything so that you can probably join our Slack channel or the meetup group later point of time. So today we're going to talk about this stack, the open source stack called Elastic Stack, also known as ELK. Many people might remember, this as Elasticsearch, Logstash, and Kibana. But over a period of time, we have added a lot of things to the stack, and then it also solves different problems, and then it became Elastic Stack, like a framework, but it's more than a framework. So specifically, we're not going to dwell deep into any one topic. We're going to talk about some concept, and then we'll also see how you can bring up this stack. So a bit more about Elastic Stack. Elasticsearch is the heart and soul of the stack, and then you have Kibana, which is the UI on top of Elasticsearch, or you can also think of it like a window to Elasticsearch, and then which helps you to look at everything, right? Not just about data, but about even monitoring what is happening in Elasticsearch. And Logstash and Beats are ingestion modules where you can push data from different places to Elasticsearch. So Elasticsearch is a distributed NoSQL, API-based, REST-based, NoSQL data store. So, and the key feature of it being is a search engine. It's a distributed search engine. And it can also serve as like, your regular NoSQL DB, but it has several other features like aggregations that help you to achieve more like a real-time analytical engine. On top of this stack, the same thing that you have seen, I just put a brick kind of a thing that you see, that stack. On top of it, we have three specific problem areas, which we call them as solutions. And then we have specific solutions that are built on top of these, namely like you have search, observability, and security. So when I say search, like I said, this regular search features. And then when I say observability, like something that we're going to talk about as a concept, and then also explain more about it. And then you also have security, which is like if I have to tell you, the anti-malware, the SIEM, if you are into SecOps and, DevSecOps and also InfoSec world, then that is where it's about the SIEM, EDR, threat detection, threat hunting, and a lot of these things. So it's multifaceted, and because of the powerful stack that we have, Elasticsearch being a distributed system, we are able to achieve, because we're trying to mold, and the Elasticsearch can be, it's like a clay, and you can mold it and use the power to, augment it to solve one of these problems. So specifically, the thing that we're discussing today, so the problem, right? Especially before dwelling into the thing. So I want to cover a bit basic about this particular problem. And when you're talking about things like observability, or when you are thinking about developing an application in a cloud platform, or even say when you are thinking about doing any sort of regular programming, right? You might be one of these personalities. You might be one of these teammates in this entire, the problem. So maybe you are a coder or a programmer who loves coding, but definitely wants less bugs, obviously, right? So you want your code to be bug free and want to make it simple, easier, and it's scalable, and a lot of these things. Then you might be a DevOps person, and then you want all the systems to function well. If you are ensuring that your services run well, you are a production engineer, like a site reliability engineer or a DevOps person, you might want to do that. Or you might be a SecOps person, like I said, who wants to secure and protect your data. Or you might be a product owner itself, like who are looking after the product performance, like say how much time does this page or service taking, whether could I improve somewhere, or many other things. If you are a product manager or a product owner who owns that particular business area, or the functionality from the code point of view, you might be one of these areas. So who doesn't want to do all of this? Like, everyone wants focus area to build better systems, scalable systems, and systems which doesn't have any bugs. So how do you achieve it? Like, what are the different things that you could do to achieve it? Like, traditionally, if you see people do, like, okay, I just, to achieve bunch of these things, I want to collect all data. Like, I just want to collect data from my application. I want to make sure collect all the logs and metrics from my systems, or I want to collect different metrics related to page load times, and many things, right? So people usually this would be the scenario where you have people or teams, if I have to say it, doing different things, collecting different metrics into different tools or different systems, right? Generally this happens, be it cloud or be it on-prem data centers. People generally do this sort of a thing, right? You have different systems to do different stuff. But what observability as a concept means, achieving this entire thing into a single place. Now, before I'm getting ahead of myself, but then before I cover more, I'll explain you some more detail into this data. So when you see this, say, for example, you're deploying an application into a Google Cloud platform. When you're doing this, you are literally, the application generates logs, the application generates metrics, the application generates some specific traces. So these things are having one common thing called the timestamp. It is happening at one single time point. So everything carries a timestamp because this is a time series data. And then you have that as a common layer. So whenever you could, when that is commonly available, and if you could, unify these things into this data into a single point of place, then as a team, you could, or as a product owner, or even as someone who is developing a specific application, you could simply point out or cherry pick any particular area and go to logs, or correlate logs, traces, or even, the metrics. You can do, bidirectional correlation. And you could also find out issues. There is no need of, when you see an exception, and you don't need to open, SSH into the machine, open the logs using VI, or probably tail-f, and then, or probably you might have a console, and then you see the logs, and then you might be seeing the exception and code the code and see what's the error. So you don't need to do all of that. So everything will be correlatable, and everything can be debugged at a single place. Now, this is nothing but, the observability, what the observability means. So it helps you to, visualize the internal states of the system, and helps you to achieve this in a holistic perspective, in a 360-degree manner, from a single point of view, from a single pane of glass, if I have to say. So that's what observability. This is a approach that generally we recommend. It's also very popular in the industry. And gone are the days where you just want to look at monitoring or a specific thing. You want to look at everything. You want to understand how things work at scale when you're building a large scale service as well, right? So talking about tools, like how can you achieve this? Like we understood the, I established a problem. I said, these are the various areas to collect the data. And then now I'm talking about what are the tools available to do that. Of course, there are many tools. I'm not specifically talking about Elastic. I'm talking about every open source tech here. So if you see, Elasticsearch is very popular for ingesting logs and metrics or different stuff. So Elasticsearch is one such tool. Then you also have the Jaeger. Jaeger is a tracing solution from CNCF. People also use it. Now there are more new things that I'm going to talk in a minute. Jaeger is a tracing solution from CNCF, which helps you to collect traces. Then you have Prometheus, which is a metric store that you can, again, in the Kubernetes world, you can simply ship the metrics using Kubernetes, or you could also scrape metrics from Kubernetes from the Prometheus, and then put it into one or the other store and analyze this. Or you can also look at another tracing solution like Zipkin, or very popular or getting Open Tracing. Open Tracing is another one which is got merged with OpenCensus. and became open telemetry now. So open telemetry is one another area that is there, very popular, where you can do logs, metrics, cases, and achieve observability. Either or, there are many other projects from Elastic itself, like the beats, the APM, etc. So there are different tools, there are different ways to go and achieve it, but what we also have is like combining each one of these and making it in a unified or a simplistic manner. So that's the whole goal, right? So that's how we want to solve this entire problem, and ability to, and helping you to do this correlation, etc. But talking about these tools, again, you might also understand, like, okay, I understand maybe there is this data that is getting shipped into, say, one of the system, and then Aravind is saying that you need to correlate all of this, you need to bring it to a single platform, etc. But do you also, you might also have this question in your mind, say that each tool might ship data in a different format, right? Or each tool might have a different structure itself, like each tool might have different schema, a lot of these things, right? How do you solve that? How do you ensure that when the data is coming from different tool, if your organization, or if you chose to go ahead with one specific thing, how do you solve that? So we have come up with another open source project which is called I'll introduce that. But what we did is like a common data schema, because we ourselves as a company, we had this similar issue, because we have our search offerings, we have our beats, which ships our data, which is like a data shipper. We have tracing, which is APM. We have security solution out of SIM and endpoint. So, and all shipping data to Elasticsearch. And there is good chance that each one ships, each engineering team might be shipping data in a different format, right? And these are things that developers use end of the day again. So we also need to be aware of this specific problem and try to do something that is correlatable, try to do something that is easy. So we have come up with another, the common data schema. It's not a software. It is it is kind of a schema document, and guidance, and using which you could implement or you could write logs. We also have some implementations for each programming language that community has developed. So Elastic Common Schema is one another project that we have come up, which helps you to do this common, correlatable common data schema. Say, like, suppose if you have an IP address in a log, if you put it through, like the beats, or even if you are not using, if you are using something like Prometheus, and then you have a metric coming out of that, and when we scrape it, we automatically convert into a common schema. When there is IP address, you'll see IP.address, and when you want to search for IP.address, you just need to search for that particular thing. There are several other partners, like, say, Cisco, Palo Alto. They were implementing this in their routers, etc., so that whenever they ship data, and then they will be able to come across this common data scheme, and then which will automatically get into this particular system. So all the data shippers that I spoke till now, like specifically Elastic data shippers, because we started this, and then we thought that we should do it first. So all the data shippers that I spoke, like Beats, and then the other shippers, it will automatically ship this data into that particular schema. So even if you are using some other Prometheus and all, we scrape that, the Beat scrape the data, then it automatically convert into the ECS. So this is one other structure to look at. So yeah, I spoke about it, and like I also spoke about this particular schema, like how it looks like. Like, say, it will convert, if the type is IP, it will convert into a specific field name. If the type is the host name, it will convert into a different sort of a thing. If it is a source, then it like source.ip, destination.ip, and then many things that are there. And end of the day, you will be able to correlate all of this. Say, if you want to check bugs or issues coming off from a specific host name, and also look at traces, logs, and everything, with one single query, you will be able to find out everything. So that's the beauty of it, this particular thing. Again, common ECS, or Elastic Common Schema, is a concept that you could implement. We have some implementations, like for jars or packages that you could use in your programming language, or anything which will ship. But if you are using something like Beats, or Elastic Agent, it will automatically ship in this format. So you don't need to do the extra heavy lifting by yourself. Now, traditionally, so even if you think of like the platform as such, that it can gather data from on-prem or any cloud platforms, and then like it can connect to each one of these, and then it can do this in this specific format. Now, here is what I think like I'll take a detour, and then I'll see if I have any questions, and also see if I could like show you the demo from here on. So from here on, we will talk more about like how do you create this on a specific cloud platform, how do you look into some of these metrics, and we'll see the dashboards, etc. So any questions till now? Okay, a bunch of questions. Okay, if you have any questions, you can feel free to ask me now or stop me in between. I'm happy to take questions at this point. No questions. Okay, so we'll go a bit ahead, and then again I'll take more questions from you people. So talking about getting started Google on Google Cloud Platform, so you could simply if you're very much into the GCP, this is a GCP console, and then you have the left menu when I pinned the marketplace, but otherwise you could also search it from the search bar here. You can go to the marketplace. We are very we are a close partner to GCP, and then there is a marketplace offering in the first featured offering from Elastic. So it is like a Elastic search service running in Google Cloud. So you could simply click on it, and then you just go through the thing. So the beauty of this is like you could still use your Google Cloud credits to purchase, or like to use that. You're not going out of the Google Cloud ecosystem. You are just still using the same thing. Okay, I think something is wrong. Great. Let me see if I am at the same correct. Oh, I'm sorry. Yeah, I need to change the account. The beauty of this is, with Google is like you use the Google account, and then you can simply get into the cloud platform. But then sometimes you might miss that there is a different account that you can do. So I'm simply clicking on the purchase part of it, and then it shows me some the terms and conditions or various other stuff, but the billing account will be same. So it also comes with a free use 1 month free term, and then shows me different details about what is the billing account that I want to authorize. I'll simply click that and then say subscribe. It will be subscribed, and then it might also sometimes say that there is a process that okay, your request has been sent to Elastic, so don't worry. So there is no other process like somebody needs to approve or something. It's already done. So and then you just come back to the same solution and then say click enable this API. So when you enable this API, it will enable the Elasticsearch service on Google Cloud. So these are the small steps that you need to take okay, before getting into this thing. I'll quickly showcase how you can spin up a cluster and do all of this easily. If you have any questions, I feel like you can definitely ask. So feel free to stop me in between as well. So I'm just clicking, so managing it via the Elasticsearch console. So from the Google Cloud, you get into this particular, the console, and it shows as Elastic Cloud, but you will still be able to spin up the workloads in the Google Cloud itself. So let me quickly create a deployment. So there are different options, like I said, search, observability, security. I could choose observability, like we spoke about it just now, but otherwise I could also choose Elastic Stack, or which brings me more hardware related options. But then if I choose Elastic Observability, it knows how to build a specific hardware profile for that particular use case. So that's why it is trying to do that. You have Google Cloud, and then you have bunch of things, because I am in India, and then I'm trying to use the local region so that it boots up fast, and then we might be able to do that. So if you see here, I have clicked on the customize button. You can choose not to and click on create deployment. but you could also like, see different options, the name, like say GDG, and then I could also choose to customize and change the RAM versions or the availability zones. Yeah, do all of that. So that is one thing. And then I saw your question, Vinu, and Vina, I think I'll just answer it in a minute. So you see that you are spinning up Elasticsearch cluster along with the Kibana and a specific thing called APM. So this is a standard, the architecture or stuff that spins up when you choose a template like Elastic Observability. You could also add, because this is not a search solution, it is not enabled, but you could enable that, and you could also provision that particular thing. But we're not gonna do that, and like we don't need to worry about that particular stuff. So let me go back and change the stuff, and then we'll come back and see if we could customize that. Even if it comes, it's fine. But this is how you could enable the search offering. You could also go and change that particular stuff. So if you want to enable machine learning, you could do all of these changes here, but we'll go with the sample and the regular, the deployment. It takes a while to deploy this particular stuff. And once it is deployed, you could, create, and you could start monitoring and look at things. Now, coming to the question, do Elasticsearch use VM or it is serverless? Elasticsearch uses VMs. It is a distributed system. That means you need to create a cluster to run this thing. But what we have done here is we are using a service just like GKE or just like a compute engine. We are just using on Google Cloud Elasticsearch service. Ideally, if you are downloading by yourself, you need to build this cluster by yourself. We're just taking a shortcut and then using this the cloud platform easily. You could also, the benefit of using this from your Google Cloud is you would get all the features, and you would also be able to get all the snapshotting, automation, the stuff, the maintenance in place, and you could focus on what you want to specifically build. Yeah, that's the answer. It is not serverless for sure. Any other questions? So while this is coming up. Okay, so this might take a bit, maybe like 2 to 3 minutes. Meanwhile, we could, go and I'll explain what I'm trying to do here. So I've already created, a instance, a compute engine VM, and we'll collect the data or the metrics from this particular, VM, and we'll see the data in the Elasticsearch console here. So let me, I have already initiated an SSH console already here. I have opened that. So I'll make it big so that, I hope this is visible, right? Oh, it has gone up. Great. Let me do sudo su so that I'll be able to do the root level stuff. So I hope this is visible. If not, I'll make it a bit bigger. I believe this is good.
Yeah, it's visible, Aravind. And we have a question from Shannon, if you want to answer it now.
Yes.
Question is, what kind of storage does it use for persistence?
Good question. So it uses SSD. So if you go to the hardware profile here, you will be able to see the what type of VM that it is using. Say, for example, if you click on create deployment, and then say we obviously provide these, IO optimized, compute optimized flavors. But if you want to see, that's why I was showing this particular thing. You'll be able to see what type of data disk it is attaching, how much disk it is getting attached. So it uses the SSDs. I believe there is a specific name. I am not sure. I forgot. I get confused with the terminology between different cloud platforms, but I think it is called persistent storage or ephemeral storage in Google Cloud. There is a disk that you could attach when you're creating VM set. So it's the same way. It uses the attached disk, and that's how it puts the storage. So it is storage that you see here. So it's attached disk, and we don't recommend. So that is another thing. You don't need to do all this configuration by yourself. yeah, specifically like you don't need to start configuring all of this by yourself. We create this cluster in this platform, and it's simple to use. So yeah, any questions? Something that you're asking? Peter and Isira, I think you
I
have
just
some.
threw into the chat, Aravind, that I was curious how many folks were already familiar with Elastic and using it. And so just taking a little quick poll in there. Just get a sense.
I think definitely we will spend some time there. That's why I was like waiting for the things to happen. So now you could see that the Kibana is up and running. So we will go a bit, I'll explain you what's special and how things, work here. But specifically what we're going to do is like, we have spin up a cluster. We're going to see the data that is coming from different places. I'll also see if I could spin up another cluster and see how a search engine works at Elastic. So all on Google Cloud, and you could get the thing easily. So let me go back and see if I could create deployment while we'll complete one use case. We'll come back and see another thing again. Splitting. So why I'm creating two clusters? Why not in one? That question might come up for some people. So we recommend keeping time series data and the search data completely different. That is the main reason. Ideally, for your time series data, for your use cases related to, say, your logging, your metrics, your traces, you can keep all of them in one specific cluster. Or even if you are having use case specific situation, then you might want to use that one specific cluster for that. But if you are using for search engine, we recommend it to put it in a different cluster. Actually, your use cases should be separate. You can't use a search cluster for you should not. It's not like you can't. You should not use. Ideally, people might try that, but it's an anti-pattern. You should not. You should not do that actually. Thanks for showing your show of hands, because that helps us to do that. So I'll simply click on Kibana. It automatically authenticates. I have downloaded the credentials, but it automatically authenticates to the SSO, and then I'll take it through the Kibana. Yeah. So let me load it. So Kibana is the window into your the Elastic stack. So Kibana is a UI, and Elasticsearch is like the database. I would give caution about not calling it as a it's relational database. It's not a relational database. It's a NoSQL DB, NoSQL data store, to be appropriately right. And then like, if I have to say that Kibana is a UI layer and it does all this magic on top of the Elasticsearch. So if you see here, I have this UI, and then like you have this some home page that you are seeing, like showing different stuff here. But if you want to collect data, or if you want to add some sample data, I would simply use the data set that is here. So I could show you how things work. So I simply click on add data, and then I'll show you some sample data. I'll also show you the Elastic agent today, and then like we can collect data coming from a different machine actually. And then if time permits, we will simply go and look at the search as well. So there is one more question from Vina saying like, can we do Elasticsearch outside of VM? So Elasticsearch is a software and it needs a place to run. So VMs are virtual machines, and then it runs the software. Suppose if I want to run Elasticsearch here, I need to download the binary and install that binary just like a software, and then run it there. So that's that thing here. So you just need to install that and run. Then it becomes a single node Elasticsearch cluster. So the machine GDG will become a one node Elasticsearch cluster. Now what we are trying to do is like create a cluster in the cloud, but this is not where it is running. This is just a simple SSH machine that is helping us to do this particular stuff. Helping us to collect the data from. So I have indexed this data now. So whenever you're putting data into Elasticsearch, you are calling it as indexing the data. You are, like inserting the data in a traditional DB world, but here you are calling as indexing because it's a search engine, and then you index the data into search engine and you ask queries to the search engine and it will give you answers. So that's what we are trying to do. And then because it has an analytical capability to analyze the data, we have a nice UI called Kibana. And then when you ingest this data and then you could crunch the data using aggregations, which is like your group by in your SQL world. And using that, we can see some sort of, nice UI. Say, for example, if you want to look at the web logs, right? Say, if you want to look at the dashboard, and you'll see we just ingested a sample log data that is there. It's sample, it's not real time. It's just sample data that we did it for the demo. So you see the bunch of the aggregations or the stuff that is there. So imagine this is the data that is going on with your application and people interacting from different places. Like say the amount of data that US is receiving from different countries for your application, or the amount of data that India is receiving, or like China is receiving. These are the web logs, and this is a Sankey diagram to showcase how the network is placed. You could see all of this. You could build by yourself. So this is something that we have built and created this dashboard. You could also do this by yourself, right? Now, let us see if you could build or look at something like this by ourselves in real time. So that's what I'm trying to show you here. So I have already created a VM. I have already created a SSH VM that you could see here. So what we need to do is collect data from this. But like I said, how do we collect data? If you remember, we spoke about beats, the data shippers in the first slide or so. I also spoke about a word about Elastic Agent through which you could collect the data. So let me show you that. And so if you see here, there is something called Ingest Manager that we have recently, released, and which is under beta. So through which you will be able to, collect the data and automatically install this agent, and then see it in the dashboard. So it's like an agent that is sitting on your cloud platform and doing all of this. So let me open that fleet and then enable it, and then add an agent so that we can start seeing the data. So you can click on add agent, and then it says that you need to download the agent. Let us go to the download the agent page, and this is a downloads page. And from on the Elastic side, I am running a Ubuntu machine. I'll just click click address. I'll see this, and then I'll do a wget here. Say downloads the stuff. Okay, let's do a stuff. Yeah, bpkg -i elastic agent. So it's trying to install, and it has installed. And then let us see if we could. So the next instructions say that, what we're trying to do is, like, if I have to repeat it again, what I'm trying to do is I'm trying to install an agent on a VM that is in Google Cloud, and pull the data from the VM to the Elasticsearch cluster that is there on Google Cloud Platform. So the cluster and the VM are separate. It's not in one place. So I'm just trying to do that. So just to clear, give more details. So in this wizard, I have done the first one. I have downloaded it. I have one configuration that I want to choose. You could also create different configs. Now, I don't want to dwell into more, details of this particular stuff, but I just want to do the simple one. So if you see that for Linux, these are the instructions, and I could go to the, let me go to the deb, and then say cd user bin. This is where, okay. This is where the Elastic Agent binary is there. So I'll click clear, then Elastic Agent. And if you see here, I have this enroll, the enrollment agent. So I'll just simply click copy. Let me see if I have copied fully or not, so that I can also click the copy. So, but I just want to make sure that I am doing the right stuff. Okay, I'll do that. Okay, I missed this one. Let me see. Okay. Oh, okay. I think I did it wrong. Anyway, no problem. Okay, it's saying that the error executing something. Let me also copy it again and do it properly, because this is the one that we need to look at. So Control C. This is the command that we need to run. I'm already in user bin. Let us see what it does. It says like, this will replace your current setting. Do you want to continue? Yes. And then it enrolls with this particular cluster that we have. So if you see here, it says that it's trying to enroll. GDG is the host name that we have seen. And then we'll quickly come back. And then we also need to enable this agent using systemctl. So if you see here, I need to enable that. It's just any other binary, and then you're installing to do this, collect the data and enable all of this. Now if you see, if you click continue, and in a minute you would see that the GDG, you would see the agent is online, and it will start collecting and showing stuff. So if you see here, it's saying the agent is already running, and there are different data sets that are enabled to collect, like the file beat and metric beat. It will collect metrics and it will collect the logs as well. So if I have to say that, now you already have this particular agent configured. We'll go back and see how we can enable the the integrations to it. So what we have done here is we have specific configurations. So when you have this agent installed, you could choose what data to be collected. Like say you want to collect specific Apache related stuff, or a cloud related stuff, or containers, or if you have any data stores. These are the configuration sets which automatically allows you to collect this thing by default. So now we already have two things that are already enabled in our agent, like the the endpoint and the system integration. So it will automatically connect the system level data, and there is a detailed description on what data is being collected and different stuff here. I'm not going to go deep into it, because maybe it's so like so much to consume in the first place, but I'm just showing simply like these are the agent and integrations. Now, like I said, if you go here, it shows me what dashboards are added, how many saved searches or visualizations that are there, that are available. So let me go here and see if we are already having any data that is being collected. So it says like this amount of data is collected, namespace is one, data sets, etc. You can come to the dashboards, or you could come to the observability, because we are trying to collect data and see the observability thing. The observability pane, you could see that the logs and then the metrics, and then of one machine that we are collecting right now. And you could also see if you have these enabled. If you're running an Apache server and running an application, then you can add APM. If you are running a service, you could monitor the service using this thing. So yeah, so all of this is possible. Just we have done a basic, very simple end-to-end for observability. There are many things that you could do, and I know if you have I think we have still only 20 minutes. I want to take some questions, but if you want to do a full-fledged, right, if you want to understand more of these, there is a demo site called demo.elastic.co. On which you could see all of this with more amount of data being collected from different applications, etc. Like say the same Nginx, the inbound traffic, and if you are running in something like GKE, you'll also be able to see this the waffle map, wherein this is a GKE deployment, and you'll be able to see. I think we are in GCP itself. It will also support multi-cloud. We have some services in DigitalOcean, but then you have Google Cloud, GCP, and then you could also go and have service type. So you could different services that are running. It's not just looking at these, but you could also go and look at like say the logs of them, the metrics of them, the APM traces. Let me show you, and the bugs that are available. So you're not doing full end-to-end, but I want to show you that all of this can be possible, can be built. using this stuff. And you could also go and take and browse this thing. But this is how you build this. So any questions? So this is how you getting started with, Google Cloud and Elasticsearch. So if you have any questions, I'm happy to take. So I think there are some.
There are a few questions. Aravind. We start with. Okay. First question is from Paul. For the monitoring of Elastic clusters themselves, is it the best practice to have a dedicated monitoring cluster that the clusters report to versus self-monitoring?
So, if I have to tell you, I need more information in general. So I'll tell you in a use case. Suppose if I am a e-commerce company like eBay, and then I have a bunch of infrastructure running in any cloud or a data center, and then I want to collect logs, I want to collect metrics, I want to collect traces. Now, this is what we have spoken. And then this is a large scale global service I have in US and North America. I have in Europe, EMEA, and also I have in APAC. So I have 3 different stuff. The scale of service is quite big, and the scale of business is also quite big. So now if I want to monitor this infrastructure, I could start with something like a service or a specific cluster only for collecting these details, like the logs, metrics, and traces, only for these, a specific cluster for that. And whatever you call internally, be it monitoring, be it observability, be it analytics, be it DevOps, whatever you want to call it, but this has to be separate. Okay. I'm not saying create one for logs, create for one for metrics, one for traces. No, it should all ideally in the observability standpoint, it should be in one cluster, and it should be separate cluster. It should not be with any other use case, like problem use case like search or security. It should not be with the other one, because what anti-pattern that I generally observe with a lot of users is generally people, because Elasticsearch is working, it's fast, it can crunch a large amount of data, will start shipping a lot of data from different data sources and different tenures into one single cluster, which might not be able to, which is not a right approach to do that. But that doesn't mean that Elasticsearch can't handle large scale data. No, I have seen in one of the large e-commerce companies, they ship a terabyte of data per day, and it's only logs. It's not other data sources. It's just only logs that they ship terabyte of data, and they have a petabyte size cluster. It can scale, but what we want to talk about is data has different tenures. So some data has life around 3 months or 6 months. Some data is forever. For example, your products in your search engine is forever. It doesn't expire over a period of time, right? So the analytics that is generated out of that search engine might have a different time period, right? It might have a different lifetime actually. So yeah, that's what I want to explain. So if I'm getting it right, Paul. So if you have more questions, I'm happy to answer. Yeah.
Aravind, this is Abhilash. So to add to that, what I want to say is that you can do it in the same cluster itself, but just ensure that your data is not exponentially growing, right? So I mean, you might want to look into something known as index lifecycle management, only for the monitoring. Indexes, so that your indexes are basically evicted after a certain period of time.
Exactly. Thank you for Abhilash for adding that point. So you have different mechanisms that are there, and what you could do is treat your data you can say that you can run it like a cron job. In your index lifecycle management is like your cron job, and what you do is you kind of set some timelines and say, I want to extract this much amount of the insights from this data, but I don't want this data to stay in my cluster for a long time. I just want to cut the cake and remove that piece altogether and move it to somewhere a cloud storage like GCS, and then you can keep the insights and remove this. So that's what people do. Yeah. So I could see one more question from Zim, or like Vishal, it's your order. You can tell me.
Okay, yeah. The next question we had is, what is recommended way to install agent if using Kubernetes engine GKE by Shannon?
Okay, so good question again, because I think the agent is in beta, so we want to definitely support all forms of stuff like Kubernetes and all deployment things. You could always download it and run it in a daemon set and start collecting the data by default, because it's there. It's all there. We're already building it for Mac, Windows, Linux, everything. And this agent is like an agent which will collect your logs, metrics, and it also contains an anti-malware component if you want to enable it. So it will also protect like your antivirus in your enterprise systems. So that is there. So there is also a specific set of instructions that are there here that I didn't show you this, but I went to the Kibana flow. So that's there. But today, if you want to go to the production and use this stuff, I would definitely recommend you to run, let me go to the downloads page again. Okay, I should have clicked this. Okay, you need to look at these beats. So what we have essentially done is like here, we have unified all these beats, multiple beats into one agent called Elastic Agent. These are open source data shippers that we have, which will ship in different types of data. So if you really want to start today, there is a page again, I could take you through that, which helps you to, how do you run in the Kubernetes, how do you run a daemon set? And then how do you collect data and ship it to the Elasticsearch cluster that is there on either one of the cloud, and how easy to get started. So you need to look at this if you are going to go to production tomorrow and start doing that. But otherwise, this is a cool tech that we are building, and we are gonna definitely looking forward to make it GA. But at this point of time, it is beta, and ideally we don't take much amount of time to move things from beta to GA. You could try it as a POC, but not in production as of now. But you could start looking at things. So
okay.
Yeah.
Then we had one question from Veena. She was asking, does that mean after we downloaded the Elasticsearch, can it be used as a service by using the HTTP link?
Yeah, exactly. So that's what. So if you see here, I have these the cluster that is deployed. Now I have this Elasticsearch Kibana. I can click copy endpoint, and if I have the username password, which I do, so if I click here, it will ask me the username password. I click Elastic, and then I type the username password. It is a cluster that is available on HTTP. HTTPS in this case, but you can. That's how the things work. So everything is on API. You just need to run the software, and the API is there, and you can start asking questions. Here, like using the search endpoint, everything. Even in the Kibana, you could go and look at the dev tools console, through which you'll be able to run these queries by default and see all the data, etc. So yeah, you could run it on HTTP endpoint. That's the holy grail. That's how Elasticsearch is quite popular, because it's available as a REST endpoint, and then you can do everything over an API. Yeah. Any question? I think
we have a question from Baris. He asked, can you explain one more about cluster and VM being separate? Once more, maybe. Yeah.
Okay, good. I think I'll try to show you something, and then that would give you more information. Let me try to pick up that, because there are more getting started folks, and then I have a interesting, getting started guide, and I believe you will all like it. Just give me a moment to pick that up. Okay. Okay, I opened it. Let me share the screen. Where is this? So for many folks, if you are new to the distributed ecosystem, and all this stuff, it might sound a bit odd or to grasp things simply. but don't need to worry in general, because you are no more, you don't need to worry about the entire, the spectrum of how do I build this, how do I download it, whether it is cluster, whether it is a VM, what is the difference between cluster and a VM, how do I do all of this. So you don't need to worry about all of that, because right now it's all cloud, and you just do some few clicks, and then things work automatically. So let me show you this stuff here. Okay. So I hope you could see this, right, Vishal?
Yeah, we can see the screen.
Okay, great. So if you see that these black ones are VMs, okay? And then think that these black ones are VMs, or your individual machines, or your laptops itself. Each one is laptop, can also be a computing machine. So these colored things are indexes. And you see, in the true distributed sense, the data is spread across the cluster. Data is not sitting in one place, it is spread across. When you ask a question to this particular thing, it acts as a single system, which is called as a cluster, which we are calling as an Elasticsearch cluster, and then it gives you an answer. Okay, so that's what is happening here. So when I'm talking to Elasticsearch, that means I'm talking to all three nodes together. It abstracts away the complexity to you. It spreads the data all across, and then it helps you to leverage the parallel computing. It also scales horizontally and does all these things behind the scenes. Now with cloud, what we have achieved here is we are simply using this, the Google Cloud and this platform, and simply building a similar sort of a cluster. In the last 30 minutes or so, we have simply built a simple cluster like this, and build and ingested the data into this cluster. In real world, if you, this is real world, but if you really want to do this by yourself, you need to go download this thing, spin up 3 VMs, or 1 VM or 2 VMs even, and then install this software, and then run it and make sure the clustering happens. And you need to make sure that that thing happens, and then you need to build this thing. And frankly, many people do that as well. This is just a much easier and much better way, in a way, in the cloud world to do stuff. This is like a cloud service of Elasticsearch. Yeah. So that's how I want to explain more on cluster and VM. I hope that that answer the stuff. Cluster and VM are not separate. Cluster is all together, a bunch of VMs actually.
And then we had, can you configure Elasticsearch to only keep a smaller amount of data, like last 6 months of logs?
Yeah. So like what Abhilash has told, like you see here, where is that? I don't know. Okay, this one. Yes. So if you see here in the settings, you have the index lifecycle policies, and which says that, okay, rollover over 30 days, roll over a specific events, and you can configure all of this. And then you can set if it completes 180 days, and then simply cut the data and push it, or delete it, or move to some place, or like do some specific query. You can do all of that pretty easily. I'll read the question, Vishal. Raj is asking, like, you can show the, yeah, that's what I was talking about, the ILM. This is how the ILM works. It also works on the API. I'm showing the UI in the Kibana. So that's also there. So everything that you see in Elastic, it is also available as an API in the Elasticsearch as well. Okay.
There were a couple more questions in the chat.
Yeah, I was saying that. So there's another question from Lokesh saying that, how can we monitor the network devices using ELK, or how can we ship network devices data into ELK? So, okay. So specifically when you're talking about Elastic Agent, it's quite simple. You could enable the Elastic Agent and start monitoring some networking stuff. So that is one way, but because it's in beta and I want to talk more about it, so you could download the packet beat, and packet beat is more around network and network packet data. And it has a bunch of modules that enable you to do that. Packet beat is one. You also have audit beat, which does integrity monitoring, file integrity monitoring on any Samba share kind of a place. Now, if I have to show you the network, I don't know whether we have any data here already, but then the SIM app automatically collects this data that is already there. If you see here, I have the host GDG, and I'm surprised that there are already 4 login failures. So this is security data. I'm collecting the host data, network data, and I can also collect data from router logs using the SNMP Polar plugin from Logstash. To do a lot of stuff, So yeah, so that's how you could collect. You could use PacketBeat or you could use Elastic Agent. If you are trying to do a POC, I would recommend you to do that. Okay, so I hope that I answered the question. And then another question from Jim: do you have any advice for using Elasticsearch as the search tool for a knowledge base, which includes Word documents and PDFs? Yep, you have. You should definitely go and look at Workplace Search. I believe that I don't have a demo to show at this point of time here immediately because it takes some time to do that. But other than that, you should definitely go and look at Workplace Search, which you could ingest Word documents, PDFs, Excels. You could also connect third-party data sources like Slack, which is coming very soon. Then you also have Gmail as a connector. You could unify all the data sources, content data sources like G Drive, Gmail, Jira, Confluence, if I'm pronouncing it right. And then there are multiple of these systems, and then you can collect all the data, and then you can create a knowledge base. If you are looking at something around a simple data where you have case management, you want to do case management kind of a thing, and you have data in a RDBMS system, you could also go and look at app search. That is another one to look at. So these come in the search area. Yes, many people do that using Elasticsearch as well.
Thanks everyone for joining. As Vishal said, you can definitely find us on the community Slack channel, and I hope to see you all join there. And if you haven't already joined our Elastic virtual user groups, you can go to the community.elastic.co website and join our user groups, or subscribe to our YouTube channel, and we'll see you out there at the next meetup soon. Thanks so much. Bye, everybody.
Thank you, everyone. Good day.
Thank you, everyone. Bye. See you
Thank
all
you,
at our next
Aravind.
event.